In this tutorial, we are going to see how to deal with seasonality and forecasting using the period-by-period method. If you have not done so, please view the introductory video first. Additionally, make sure that this approach to seasonality matches the one in your textbook. Keep in mind that there are several different approaches, so match your textbook. Working with an even number of periods requires one additional step, so we will begin by looking at how to work with seasons that have an odd number of periods. Using the data shown on the slide, we wish to prepare a forecast for next week using simple regression and adjusted for seasonality. Our first step is to prepare a chart of the data and check that seasonality actually exists. That chart is shown on the slide. As you can see, demand is increasing, so it will have a positive trend. You can also see a regular, repeating pattern of up and down movement, so seasonality is present. The second step is to prepare a moving average where the number of terms in the moving average matches the number of periods in the seasonality. Since this is daily demand, we prepare a 7-period moving average. The moving average will be calculated exactly the same way as simple moving averages we used in a prior tutorial to forecast with. However, when we averaged, say, periods 1 through 4, we wrote the resulting value down in the next period, or period 5 in this case. Technically, that is what is known as a forward-ended simple moving average. For seasonality, we will write the average down in the center. So the center of periods 1 through 7 is 1 plus 7 equals 8 divided by 2, or 4. The next average would include periods 2 through 8 and would go in 2 plus 8 equals 10 divided by 2 equals 5. That is, once you find the place for the first moving average, the remainders just go in succeeding periods. As a preview, this explains why cycles with an even number of periods require an additional step. If we had quarterly data, we would average periods 1 through 4 to start. 1 plus 4 equals 5 divided by 2 equals 2.5, so we do not have a period number for the resulting average. We will see how to resolve this later in this tutorial. We will be computing a 7-period moving average with the first average going into period 4. 122 plus 106 plus 145 plus 125 plus 167 plus 185 plus 230 divided by 7 equals 154.3. Note that we will be using one decimal point with all the moving averages. It would not hurt to include more, but there's no real value in having more. 106 plus 145 plus 125 plus 167 plus 185 plus 230 plus 119 divided by 7 equals 153.9. 145 plus 125 plus 167 plus 185 plus 230 plus 119 plus 123 divided by 7 equals 156.3. 125 plus 167 plus 185 plus 230 plus 119 plus 123 plus 141 divided by 7 equals 155.7. 167 plus 185 plus 230 plus 119 plus 123 plus 141 plus 116 divided by 7 equals 154.4. 185 plus 230 plus 119 plus 123 plus 141 plus 116 plus 171 divided by 7 equals 155.0. 230 plus 119 plus 123 plus 141 plus 116 plus 171 plus 208 divided by 7 equals 158.3. 119 plus 123 plus 141 plus 116 plus 171 plus 208 plus 226 divided by 7 equals 157.7. 123 plus 141 plus 116 plus 171 plus 208 plus 226 plus 140 divided by 7 equals 160.7. 141 plus 116 plus 171 plus 208 plus 226 plus 140 plus 119 divided by 7 equals 160.1. 116 plus 171 plus 208 plus 226 plus 140 plus 119 plus 147 divided by 7 equals 161.0. 171 plus 208 plus 226 plus 140 plus 119 plus 147 plus 114 divided by 7 equals 160.7. 208 plus 226 plus 140 plus 119 plus 147 plus 114 plus 185 divided by 7 equals 162.7. 226 plus 140 plus 119 plus 147 plus 114 plus 185 plus 207 divided by 7 equals 162.6. 140 plus 119 plus 147 plus 114 plus 185 plus 207 plus 233 divided by 7 equals 163.6. The slide shows a chart comparing the actual data with the moving averages. Notice how the moving averages are fairly flat. All of the seasonality has been averaged out. For those periods where we have both values, we next compute the actual divided by the moving average for that period. This gives us the percentage that the demand in that period deviates from the average. That deviation is due to seasonality. 125 divided by 154.3 equals 0.81. 167 divided by 153.9 equals 1.09. 185 divided by 156.3 equals 1.18. 230 divided by 155.7 equals 1.48. 119 divided by 154.4 equals 0.77. 123 divided by 155.0 equals 0.79. 141 divided by 158.3 equals 0.89. 116 divided by 157.7 equals 0.74. 171 divided by 160.7 equals 1.06. 208 divided by 160.1 equals 1.30. 226 divided by 161.0 equals 1.40. 140 divided by 160.7 equals 0.87. 119 divided by 162.7 equals 0.73. 147 divided by 162.6 equals 0.90. 114 divided by 163.6 equals 0.70. We are now ready to calculate the indices. These are found by averaging all the actuals divided by the moving average values for a particular period. So, for Monday, 0.77 and 0.87 average to 0.82. What this says is that the demand on Monday is 82% of the average demand. For Tuesday, 0.79 and 0.73 average to 0.76. For Wednesday, 0.89 and 0.90 average to 0.90. For Thursday, 0.81, 0.74, and 0.70 average to 0.75. It is okay that Thursday has 3 points to average and all of the other days have 2 points. This inequality usually happens and is just a result of the process. For Friday, 1.09 and 1.06 average to 1.07. What this says is that demand on Friday is 7% higher than the average demand. For Saturday, 1.18 and 1.30 average to 1.24. For Sunday, 1.48 and 1.40 average to 1.44. At this point, we have the indices. The moving averages and actuals divided by moving average columns are no longer needed. They were simply working calculations to get to the indices. We are now ready to deseasonalize the actual demand values. Notice on the slide we have the actual values with the appropriate seasonal indices beside it. That is, the Monday value of 0.82 is beside all the Mondays, the Tuesday value of 0.76 is beside all the Tuesdays, and so on. Also notice that we're using all the values and not just the ones that had a moving average beside them earlier. To deseasonalize, we divide. 122 divided by 0.82 equals 148.6. 106 divided by 0.76 equals 139.0. 145 divided by 0.90 equals 161.6. 125 divided by 0.75 equals 167.2. 167 divided by 1.07 equals 155.4. 185 divided by 1.24 equals 149.0. 230 divided by 1.44 equals 159.7. 119 divided by 0.82 equals 145.0. 123 divided by 0.76 equals 161.3. 141 divided by 0.90 equals 157.1. 116 divided by 0.75 equals 155.2. 171 divided by 1.07 equals 159.1. 208 divided by 1.24 equals 167.6. 226 divided by 1.44 equals 156.9. 140 divided by 0.82 equals 170.6. 119 divided by 0.76 equals 156.1. 147 divided by 0.90 equals 163.8. 114 divided by 0.75 equals 152.5. 185 divided by 1.07 equals 172.1. 207 divided by 1.24 equals 166.8. 233 divided by 1.44 equals 161.8. The chart on the slide shows the actual demand in blue and the deseasonalized demand in orange. Notice how much less spiky the deseasonal demand is. The next step is to prepare a forecast using simple regression. Simple regression forecasting was covered in an earlier tutorial and will not be discussed in much detail here. If you have questions, refer to that tutorial. The deseasonalized demand is used as the dependent or y variable. A period number going from 1 to 21 is used for the independent or x variable. That gives us an intercept of 150.65 and a slope of 0.70. Using the intercept of 150.65 and the slope of 0.70, we prepare a forecast for the 21 periods for which we have actual data, as well as the next full week, or periods 22 through 28. Those results are shown on the slide. The deseasonalized forecast on the prior slide was produced by simple regression, so it is a straight line. We now need to add the seasonality to the forecast. We deseasonalize by dividing by the seasonal index. To seasonalize, we do the reverse and multiply. On the slide, the entire forecast is seasonalized. For this tutorial, we will only review periods 22 through 28. Notice that the appropriate seasonal index has been included on each row of the forecast. For period 22, which is a Monday, the deseasonalized forecast of 166.1 times the Monday seasonal index of 0.82 equals 136.4. For period 23, which is a Tuesday, 166.8 times 0.76 equals 127.2. For period 24, which is a Wednesday, 167.5 times 0.90 equals 150.4. For period 25, which is a Thursday, 168.2 times 0.75 equals 125.8. For period 26, which is a Friday, 169.0 times 1.07 equals 181.6. For period 27, which is a Saturday, 169.7 times 1.24 equals 210.6. For period 28, which is a Sunday, 170.4 times 1.44 equals 245.4. This completes the seasonal forecast. The slide shows a chart of the resulting seasonal forecast. Notice how well the forecast in orange tracks the actuals in blue. Additionally, notice how the forecast for periods 22 through 28 closely follows the pattern seen in the actuals in periods 1 through 21. Using the second set of data shown on the slide, we wish to prepare a forecast for next week using simple regression and adjusted for seasonality. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. As you've seen already, these problems repeat the same steps over and over. Since you've seen all the steps once, I will be somewhat briefer in the remaining tutorials. I will continue to show all of the major steps, but when it comes to repeating the same calculations, I will only narrate a few examples of each. Of course, all of the results will continue to be shown on the slides. Our first step is to prepare a chart of the data and check that seasonality actually exists. That chart is shown on the slide. As you can see, there is a regular repeating pattern of up and down movements, so seasonality is present. It is not so clear that the data has an underlying trend. After checking the chart, the next step is to compute the centered moving averages. As before, the first one is placed in the 1 plus 7 equals 8 divided by 2 equals 4 position, and the rest follow along. For the first moving average, 281, 240, 320, 165, 310, 162, and 106 all average to 226.3. For the second moving average, 240, 320, 165, 310, 162, 106, and 281 all average to 226.3. It is just a coincidence that the first two moving averages are the same. For the third moving average, 320, 165, 310, 162, 106, 281, and 193 all average to 219.6. For the fourth moving average, 165, 310, 162, 106, 281, 193, and 270 all average to 212.4. For the fifth moving average, 310, 162, 106, 281, 193, 270, and 240 all average to 223.1. The remaining moving averages are computed the same way. Now that we have all the moving averages, the next step is to take each matched pair of actual and moving averages and divide the actual by its moving average. 165 divided by 226.3 equals 0.73. 310 divided by 226.3 equals 1.37. 162 divided by 219.6 equals 0.74. 106 divided by 212.4 equals 0.50. 281 divided by 223.1 equals 1.26. The remaining ratios are computed the same way. Now that we have all the actuals divided by the moving averages, the next step is to compute the indices. We do that by averaging all the actuals divided by the moving averages for each period. For Monday, 1.26 and 1.27 average to 1.26. For Tuesday, 0.85 and 0.88 average to 0.87. For Wednesday, 1.21 and 1.48 average to 1.35. For Thursday, 0.73, 1.08, and 0.77 average to 0.86. For Friday, 1.37 and 1.50 average to 1.43. For Saturday, 0.74 and 0.61 average to 0.68. Finally, for Sunday, 0.50 and 0.46 average to 0.48. The next step is to compute deseasonalized demand by dividing each actual value by its associated seasonal index. 281 divided by 1.26 equals 222.4. 240 divided by 0.87 equals 277.0. 320 divided by 1.35 equals 237.9. 165 divided by 0.86 equals 192.1. 310 divided by 1.43 equals 216.4. The rest are, of course, calculated the same way. Now that we have the deseasonalized demand, the next step is to find the simple regression parameters. Those are an intercept of 230.20 and a slope of negative 0.32. The slope is very close to 0, which is what we would expect since the chart shown earlier had very little trend to it. The next step is to use those simple regression parameters to produce a forecast going one full cycle into the future. The forecast of the historical values for periods 1 through 21 and the forecast periods of 22 through 28 are shown on the slide. The next step is to seasonalize the forecast by multiplying the deseasonalized forecast times the seasonal index. For period 22, 223.2 times 1.26 equals 282.0. For period 23, 222.9 times 0.87 equals 193.2. For period 24, 222.6 times 1.35 equals 299.5. For period 25, 222.3 times 0.86 equals 190.9. For period 26, 222.0 times 1.43 equals 318.0. For period 27, 221.6 times 0.68 equals 149.8. For period 28, 221.3 times 0.48 equals 105.9. Of course, the historical values in periods 1 through 21 were seasonalized the same way. This slide shows a chart of the resulting seasonal forecast. Notice how well the forecast in orange tracks the actuals in blue. Additionally, notice how the forecast for periods 22 through 28 closely follows the pattern seen in the actual in periods 1 through 21. Now that we've seen how to handle an odd number of periods, we need to look at seasonality with an even number of periods. With an even number of periods, all the calculations are the same as with the odd number of periods, only with one additional step. Except for that one additional step, the narration for these examples will be very brief since you have seen all of the other steps twice now. Using the set of quarterly data shown on the slide, we wish to prepare a forecast for next year using simple regression and adjusting for seasonality. Since there are 4 quarters in a year, there is an even number of periods in the cycle. As before, we begin by looking at the chart of the actuals to make sure seasonality is present. As you can see from the slide, both seasonality and trend are indeed present. We begin by computing a 4-period moving average, just like we computed a 7-period moving average when we had daily actuals by week. Those values are shown on the slide. The problem is 1 plus 4 equals 5 divided by 2 equals 2.5, and there is not a 2.5 row. I have recorded the values starting in row 2, but we cannot use them like this. Thus, the need for the extra step that has been discussed. We now perform that extra step that has been discussed. This time we perform a 2-period moving average on the first 2 moving averages. Because 2.5 plus 3.5 equals 6 divided by 2 equals 3, we can now appropriately record the values in rows. For period 3, 134.25 and 144.5 average to 139.38. For period 4, 144.50 and 158.25 average to 151.38. For period 5, 158.25 and 173.50 average to 165.88. For period 6, 173.50 and 182.25 average to 177.88. For period 7, 182.25 and 184.00 average to 183.13. For period 8, 184.00 and 190.00 average to 187.00. For period 9, 190.00 and 196.76 average to 193.38. Finally, for period 10, 196.76 and 207.75 average to 202.25. Once we have these second averages, the first averages are no longer needed and can be discarded. From here, the problem proceeds exactly as it would if we had an odd number of periods in a cycle. Using the second moving averages, we divide the actuals by their associated moving averages. Those results are shown on the slide. Next, we average the actual divided by the moving average for each quarter to get the seasonal index for that quarter. Those results are shown on the slide. Using the seasonal indices, we deseasonalize historical demand. Those results are shown on the slide. Using the deseasonalized demand, we find the simple regression parameters. They are an intercept of 111.73 and a slope of 9.71. Using the intercept of 111.73 and slope of 9.71, we next compute a deseasonalized forecast. Those results are shown on the slide. Using the seasonal indices, we get our final forecast by seasonalizing the deseasonalized forecast. Those results are shown on the slide. The slide shows a chart comparing the actual demand with the seasonalized forecast.
If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.